Okay, welcome to this video lecture series on basic surveying, and today we are going to start a new module. This is module number 4. This module number 4 is about compass surveying. Now, in the case of the compass surveying, we will be talking about various things, beginning with the lecture number 1. You must have heard of the compass, the word. And we will try to cover this entire compass surveying in this module 4 in 2 lectures. Here in module number 3, and the module number 3, it was about linear measurements. So what we saw in the case of the linear measurements, we saw various methods by which we can measure the distances. We started with the chain, tape, and then we went to some modern techniques, for example the EDMI, the electronic distance measuring instrument. So using all these we can measure the distances. There are some more methods for measuring the distances. We didn't touch all of them. For example, there is tachometry. Some other optical methods are there by which we can measure the distances, but the methods which we have touched are the ones which are more common and which we should know. And while talking about this linear measurements, we saw many associated concepts. You know, what is the meaning of the distance in surveying? How do we measure it if it is we are using the chain? We need to carry out the ranging. Why do we carry out the ranging? In order to establish intermediate points between the 2 points where we are going to measure the distance. What are the methods of the ranging? Then we saw, can we really make use of chain or tape in order to make a map? And we saw, yes, we can make a little map using chain and tape. What we are doing in that case, we are measuring the chainage and we are taking the offsets. Chainage, the distance along the survey line; offset, the distance of a detail from the chain or from the survey line. And using these measurements, the offsets could be perpendicular offset, oblique offset. So whatever the way we have recorded these in our field book. Field book was observations as well as a rough map of the area. We take it to the laboratory, to our office, and we can make a map. So this is what we have seen. Then we looked into detail of the EDMI. Why do we use the EDMI? What do we do with the EDMI? How do we specify the accuracy of the EDMI? So this is all we have done so far. And today we will start talking about the compass surveying. In compass surveying, first, before we go further to the compass, we will see the concept of traverse. Once we start talking about this, then the things will become more clear to us. That what is a traverse? Some definitions of open and closed traverse. We will look into the meridian, which could be true, magnetic, or arbitrary. We will look into the how we designate the bearing. Right now the bearing word may not be very clear to you, but once we discuss it, it will become clear to you. What is the meaning of bearing? What are the systems in which we record it? The WCB and the QB. And then finally, some computations for the bearing. And we'll look into one compass instrument, which is the prismatic compass, which is mostly used instrument. We'll also try to see in some other instrument also, which is the surveyor's compass. So this is what we are going to talk about today. Okay, so in compass surveying, we will be making use of the compass as is obvious. But before we get into it, let us see that why we need really the compass surveying. Some basic concepts. Let us start talking about the mapping. And we have done a map using chain and tape. If you remember what we did in that case, we had a linear kind of stretch and we saw that it was around maybe 120 meter long and some 40 meter wide. Then there were various things here, maybe a road, some houses or some trees. in order to make a map of this area, what we did, we stretched our chain here, or rather I will say this is the survey line, and in this survey line these two A and B are the survey stations. We stretch our chain along this survey line because the chain is 30 meter only, so it will only cover a little part of the survey line. So in order to do that, we need to do the ranging. Then later on, for each object, for example here we start taking the offsets, any object here we start taking the offsets, and by taking these offsets of the objects from the survey line, we record the chainage. So the chainage was distance along the survey line, and the offset is the distance of the detail. So using this we can do the mapping, we can make the map, we can plot the map. Now I am going to pose a question. The question is, can we really use this method everywhere in all the circumstances? Now start thinking about it, that is it really possible? I am going to give you another example. Let us say our area is now, that's our area, and here it is 200 meter long, and also it is 150 meter wide, and the area has, as usual, maybe some roads or some houses or maybe some trees here. That's our area. We want to make a map of this area. If you go with the usual method, well, I stretch a tape or chain here. That's my chain line or the survey line, A and B. Conceptually it looks all right. Yes, why can't we do it? Well, we start taking the offsets and measuring the chainage. So we are measuring the chainage and taking the offsets. Now for this boundary here, can you guess what will be the length of the offset? The offset will be around 75 meter long. While you are working with the tape, how do we make the offsets in the field? We have to erect the perpendicular or the oblique offsets, and we swing the tape in order to make it perpendicular. If you swing your tape, which is 75 meter long, can you think of? It's not possible. Or otherwise also, measuring this entire boundary, taking so many offsets of the order of 75 meter, it's not advisable. Now here in this case, maybe you can measure the distances, but there might be some cases where the distance you cannot measure also. You want to take the offset to this point, but there is a building here. We cannot take this offset. So what is there? We cannot really make the map like this. Well, one solution could be, if some of you may be thinking like this, for the same area, which is 200 meter and 150 meter. Well, someone can say, for these, the road, these houses and the usual trees, well, can we do one more thing? I have one chain line here, another chain line here, another chain line here, and one chain line here. It is AB, A dash, B dash, A double dash, B double dash, A triple dash, and B triple dash. Now we have, by taking these chain lines, what we have done, we have reduced the problem of taking the offsets. Now our offsets are smaller. I can take the offsets about this line just in its nearby area, and here also I can take the offsets. Okay, no problem as far as taking the offsets is concerned. We can take all these offsets, but will it serve the purpose? Start thinking. You have noted down this entire thing in your field book. Okay, similarly here also, this entire thing is in your field book. Here also, all these observations are in your field book. Now, when you are going to plot it in the drawing sheet, you can plot, for example, let us say this line AB as well as all these offsets. So, this entire area can be plotted. Okay? So, this entire area is plotted. Now, you can plot this area also, but there is a question now. When you are plotting this area and this area, the chain line AB and the chain line A dash B dash, how are you going to relate them? Let us say this is in our map, chain line AB. Where do I plot the chain line A dash B dash? Should it be here, A dash B dash, or should it be here, A dash B dash? Now this is important. We need to know a relationship between these chain lines also. There has to have some measurements which connect these together. If you cannot connect it, where to plot it? So, relatively they should be fixed in the ground. So, we can go for a thing like this, but we need to take some extra measurements there which relate this chain line to this chain line and this chain line to this chain line, so that we can fix them relatively also, and this is how we can plot the area. But this particular method which I just noted down is not really very efficient way of doing it. What we can do for our area, the usual things, and maybe some trees here. One better way of doing this, of relating these different lines is, can we really do a thing like this? Let us say I take a survey line which is passing near to the boundary. Then I take another one, I take another one, I take another one here, I take another one more. All these are the survey lines. Now what do you see here? We see here that we end up with A, B, C, D, E, F and G. All these are the survey stations and they are jointed by survey lines. I can measure all these lengths, that is not a problem. I can measure all these lengths because I have ensured that by these lines they pass through nearly flat area. There is no obstruction. Also at the same time, you can see it here now, taking the offset is easy. I can plot this boundary here. So while I am plotting this boundary, I am plotting with respect to the line BC, also this road. For the boundary here, I can take these as the offsets. For the boundary here, I can use the line A and F, because this line is A and F. For the boundary here, I can use line F and E. Okay, take the offsets. This tree can be plotted with respect to the same line here. This house can be plotted with respect to the line E and D, and also this boundary. Similarly here. We have taken all these observations, and in our field book, what we will have several pages of the field book. Let us say these are the pages of the field book. And over here is line AB, over here is the line BC, CD, DE, EF, and so on. And we have also the values of the chain edges, X, Y, the chain edge and the offsets, all written everywhere. And also we have the approximate or rough idea of the area, the rough drawing, rough sketch of the drawing is here in the field book. We know that how to produce it. Now using all these pages of the field book, all these are the pages of the field book. What we can do, we can combine them together in order to make the map. Well, I start with line AB. I know that I have taken the offsets and the offsets are certain values here, and I join these in order to make my boundary. Then I have got another line BC, and I also have the other set of offsets. So that it plots the other set. Similarly, by plotting this entire skeleton, because this entire skeleton can be plotted now this way, and the entire area can be plotted because we know all these offsets. For this house, for example, the offset was taken from here. For this tree, the offset was taken from here. So what we are seeing here, again the concept of working from whole to part. For our entire area here, what we did not start taking the measurements from single offset, single detail. Rather what we did, we started taking the observations in a big way. First we made a network of triangles there. So this network of triangles is the skeleton of the area. The skeleton of the area is captured. Okay, and then in our drawing sheet, we can plot this skeleton of the area. This skeleton of the area or this set of triangles are done very accurately. Well, later on we can start plotting the offsets, the individual details. So this is really the working from whole to part. First we have fixed the skeleton, the entire area. Then we are plotting the individual details. So what happens in this case, if my skeleton of the area, this net of triangles, is correct, if I am committing a little mistake here, then my boundary will shift only like this. Not that my entire map will have any impact of this. So really we are making use of the working from whole to part. So what we are saying here, we can make use of only chain or tape, because this entire survey of this triangulation can be done using only chain and tape. What you are doing there, you are establishing some stations, and you have got the ranging rods there, one ranging rod, another one, and everywhere you are measuring these distances, and these distances can be captured, can be measured using the chain or tape. So we are not carrying out any extra measurements, only the linear measurements. So using chain and tape we can do triangulation, we can plot the things. So we saw that, you know, we started with the linear thing, that we are using the chain and tape just for a linear thing, but we can use chain and tape also for a broader area, as we have seen in this case, and we can make the map using the fieldbook records. Well, there is a question. The question is, can this do in all the cases? Can chain triangulation work in all cases? Now this is where you have to think. Start thinking of your neighborhood, your school, your college campus. Can you really do chain triangulation in all those cases? I'm going to make a map here, or maybe an area. Let us say there is an area, and this is the boundary of the area. The size of the area is, for example, again 200 and 150 meter. There are couple of roads, and let's say the roads are all these are the roads here. Then there are couple of buildings. I am plotting these buildings by red color. Let us say there is one building, another building, another building, one more, and all these are the buildings, and the buildings have got height. They are high buildings. There are also, as usual, several trees. A typical area may look like this. Now your job is, you are asked, okay, go to this area and make a map. Let us start. Can we use really a single chain length? as in this case. We cannot use a single chain here in this case. We cannot use it because the area is very wide. Our offsets will be very large. There are many more problems. Can we really make the triangles? If I start thinking of making triangles here, okay, before we go for the triangulation, just using a single chain, let us say we are using a single chain here. In this area, if I put my single chain somewhere here, okay, my station A and station B. See, we cannot do the surveying using single chain. Number one, the offsets are very long. This is 150 meter of the order of 75 meter. Number two, another problem. If I need to measure an offset to this building, what will happen? This particular building is the obstruction here. This is an obstruction to this building because the buildings may be 1 story, 2 story. I am not supposed to climb over the building. So how to carry out the measurements? That's the problem. Okay, if we, as we are talking about the chain triangulation, can we use the chain triangulation then? Well, what kind of triangulation we can do here? Can we think of some triangulation scheme? The important thing is, in the case of the triangulation, all the stations, 3 stations should be intervisible. This station, this station, this station, all these 3 should be intervisible. But ensuring intervisibility here is really a problem. For example, let's say I take this as one station, another station. Where should I take the third station? These 2 are visible. Can I take the third here? I cannot, because this building is obstructing the line of sight. Here also it is obstructing the line of sight. Here also it is obstructing the line of sight. I cannot take anything here. So making a net of triangles here in this figure is really difficult. Okay, I can go for this line, a line here, maybe another one here, but it's not triangle. If I want to make it a triangle using this line, I cannot. Neither I can this, because we have lines of sights are obstructed because of these buildings. Now I have made a rough drawing here. You can think of your neighborhood, just outside the room where you are looking at this video lecture. Think of that area. So triangulation can be done in only those areas which are flat, visibility is clear. Only in those cases we can do the triangulation, but not for an area like this. So what to do? What kind of figure we can go for? Because we need to make a map. Well, the answer is, because the answer of this is no, we cannot do the triangulation. So what we can do, the answer lies in traverse. Now what is traverse? Traverse is, I will generate a traverse here. In a traverse, we do measure lengths and angles. For example, here, if I know all the internal angles here and also all the lengths, all these are observed in the field. This kind of figure is called a traverse. Now can we make a traverse here? And will the traverse solve our problem? Okay, let's start from here. That's my station A. I take a line like this, and here is intermediate station B and C. Then from B I go like this to C. From C I go like this to D. From C again I can go like this to E, then again here to F, and here G, and maybe somewhere here again, that's also an intermediate one, H. Well, we can keep going like this and we can cover the entire area. But will it solve our purpose? Well, I can take the offsets for these buildings, this tree from the line here. I can also take the offsets to these buildings from these survey lines. So now really the buildings are not obstructing. All the buildings can be plotted. All the trees can be plotted. Also the roads can be plotted. I can take these offsets in the road. Here in the road I can take these offsets to the road. So roads can be also plotted. So using these offsets the entire area can be plotted. Wherever the offset is shorter, I can take the offsets from there and I can do the plotting for the boundary line here, for example. Well, so this is, we say, the traverse. Now in the case of the traverse, what we are doing, we are taking two measurements. Number one is linear and angular. So basically a traverse could be any figure like this, where we know all these angles and the lengths. Well, in this case also, in this example, can we really plot it on our sheet, on our drawing sheet? I can take it to our field book, because in taking it to the field book, what we can do, this entire area which is highlighted can be represented A, B in the field book page, one page, A and B. So the entire area is shown here, the chain edges and the offsets. Similarly, the area here, another line, another line, another line here, all these individual lines can be recorded in the field book the way they are appearing there in the ground. Now in order to make a plot of this, in order to make a plot, what we will do, we will start with any line here, for example, and its offsets. So the things are plotted. Next, we have somehow measured the angle from here to the other one. Whatever is this angle value, so I know this line also and I can plot the offsets. Maybe another line and the offsets, because we know this angle. Now here in this figure, as you observe, the angles are mostly right angle. It appears like they are right angle, but that may not be the case always. We may have the angles which are acute angle, obtuse angles, depending on the field. Right now in this case, the road network of that area is at 90-degree angles. That's why we can do it, but that may not be the case always. So what we see here, one very important thing of the term which is called traverse. Because by measuring these lengths and these angles, we are able to relate or put them in relation to each other in our drawing sheet. So that may be a traverse here. So once this is the, and this we say the skeleton of the area. So again we are working from whole to part. The skeleton here is the traverse, and we are bringing this traverse on our drawing sheet, and then later on we are doing the plotting of the offsets. So working from whole to part, and this skeleton or the traverse helps us to put these lines together in relation to each other, because there in the field there is a relationship between this line and this line, a geometric relationship. The moment we have carried out the measurements of all the angles here and these lengths, all these lengths and angles, so this line and this line in our map also, they are geometrically related the way they are related in the ground. So this is a really important thing about the traverse. Now we will see the types of the traverse. In types of traverse, there are two types. One is open and the other one is closed. What these are? In the case of the open traverse, as you can see here, if I highlight by a different color now, the open traverse is, for example, we start from here and go here and then along this road. So all these three lines and these angles, they make an open traverse because the traverse is not closed. However, here if I go along where I am highlighting, this entire thing is closed. To explain it in the figure, an open traverse is something like this. We started our measurements and we have taken all these observations, linear and angular. We have measured these lines and these three angles. So this is our open traverse. Closed traverse, here, okay, all these lengths are measured and as well as all the angles are measured. This is the closed traverse. As you can see, depending upon the application, where should we use open and where should we use closed, that very much depends upon what kind of problem we have. For example, let us say if you have an area which is the river, well, that's our river here, and you want to plot the boundary of the river. So to plot the river bank, we need to have a traverse which will go along with the river, and we can take all these offsets. Now we have measured these lengths and these angles. So this is an open traverse. But in some other circumstances, where, for example, in a garden, that's a garden. For this garden, we need to find its area. We have to determine the area of the garden. What I will do, I will go for a traverse all along the boundary here, and I will close it. Then I am taking all these offsets. So by doing all this, by measuring the offsets and by measuring these angles, these lengths, everything measured, what we can do, we can plot it on a sheet, and then on that sheet we can plot this boundary. This boundary can be plotted on our map, and once it is plotted in our boundary, we can find the area of this using any instrument, planimeter or some other methods, putting it on a graph sheet, counting number of the squares there. So the area of the boundary can be determined. So in these cases, we need to go for the open traverse. Otherwise also the open traverse is better. Why it is better? The closed one. The closed is better. The closed is better. Why closed is better? Because in the case of the closed, you have a check. For example, here, if we have 1, 2, 3, 4, 5 and 6 internal angles measured. So you know what should be the sum of I1 to 6. What should be the sum of all these angles? For a traverse, for a closed figure, you know it theoretically, and you are measuring this also in the field. Then you have a check. If the measurements in the field deviate by large amount from the theoretical sum, you suspect, no, there is something wrong in your survey. But this thing cannot be done in case of the open traverse, because there is no check as such. Okay, having seen this concept of the traverse, where we need to measure the length and angle, now we will go for the compass, because compass makes it possible to measure the angles, while the lengths we can measure still with our EDMI or tape or chain. So in the case of the compass, before we talk about the compass, let's talk some terms, some definitions. Number one, we will start with the meridian. Meridian is nothing but a reference plane. Okay, for example, if I want to measure an angle, right now what I can do, I can take this plane as a reference plane in front of me, and I need to measure an angle over here. So at this point where I am standing, if the meridian is passing through me a plane, I can measure the horizontal angle. Okay, so we need a reference. Now the references which we can use are, number one is the true meridian. Now true meridian, what is it? If you can think of, just imagine, we have our earth. Now on the earth, there are the geographical north and south. You can think of that, you have to use your imagination. Geographical north and south. I'm standing somewhere on this earth here. Let us say for you, you're standing here. Now the point where you are standing, the geographical north and the geographical south. If you join all these three, it will make a plane. Or we can say it will make a great circle, a circle on the surface of the earth. So all such planes or circles which we can make on the surface of the earth are called the true meridian. Now how many of these will be? Infinite, because a person could be anywhere on the surface of the earth. And in each case there could be one possible great circle or one possible plane which is consisting of the axis of rotation or axis of spin of the earth and the observer. So just keep that in your mind. Right now also if I am standing here, there is, for example, if the north is here, south is here, and there is a plane passing through me as an observer. So that this plane is the meridian, true meridian. Now how do we establish this? True meridians are established at any area, at any point, using the observations to the sun or astronomical bodies. And these are constant. The true meridian at this place will not change. Okay? And we can use it as a reference. For a small survey, for example, because our earth is like this, so all these true meridians will converge. They're in the poles. But for a small area, very small survey, we can consider the true meridians to be parallel. For example, here only, there is one true meridian over here, another one here, another one here. So a series of true meridians. Though all these true meridians, they converge at poles, but we can consider for a small area them to be parallel. So these are the parallel lines as such, or parallel references. Generally we don't use true meridian in our usual surveys because establishing true meridian is tough, it's difficult. What we use is the magnetic or the magnetic meridian. Let us define it. If I have got a needle here, the magnetic needle, and I suspend it freely, what will happen after vibrating it for some time? It will align itself along the force line, the magnetic forces of the earth, and it will align so along the magnetic north and magnetic south of the earth. Okay, because we can think of the earth, if that's our earth here, we have the magnetic lines passing through north and south. So at any point our needle will align itself along these lines. Now as you can see, getting a magnetic needle is very easy, it's not tough. So we can say establishing a magnetic meridian is also easy. You just take a magnetic needle, suspend it, the direction it is making is the meridian. So we can define it as, a plane in which our magnetic needle has oriented itself. Again, for a small area, we can consider these magnetic meridians also to be parallel to each other, while for entire earth they converge again in the poles, magnetic poles. We also use one more term that is called arbitrary meridian. Arbitrary means it is neither magnetic nor true. For example, right now I say, well, I have to establish a meridian, and I take a line, any line from where I am standing, and there is a tree. Well, this line or this plane is a meridian, arbitrary meridian. Then in order to measure any angles, I start measuring the angles from here. So I can establish these arbitrary meridians also there in the ground. Having seen these meridians, the another term which we will see is bearing. So mostly we use magnetic meridian in the field. All our surveying instruments, mostly they will have the magnetic meridian. They will measure the magnetic, establish the magnetic meridian. Now this bearing also, if our meridian is this, let's say it is north, we are standing here at any point, and the point where I am standing is A, and there is a line or another point here B. Over here is a ranging rod, and this is the point where I'm standing. Okay, we can take it here. I'm standing at A, somewhere there is ranging rod, and I want to measure now bearing of this ranging rod with respect to the magnetic meridian. So what is the meaning of that? The bearing means this angle theta. So we are using this reference. So the bearing could be true, it could be magnetic or arbitrary, depending what meridian we are using. So that's the meaning of the bearing. Now how do we make use of the bearing? This is what we will see now. Okay, in order to understand the use of bearings, we will have to understand the systems. How do we write the bearings? The very first system is called WCB, which stands for whole circle bearing. Now what is this? Now in the case of the whole circle bearing, or let me do it the other way around, we are talking about the systems in which we can write the bearings. Let us say the direction of north at a particular point is this, or this is the magnetic meridian. I write N here. We have a line or a ranging rod somewhere here, and a ranging rod here, and a ranging rod here and here. A, B, C and D, and the observer is at O. I want to measure the bearings. So the bearings will be measured as, for example, the angle here, the angle here, and maybe this angle and this angle. So the whole circle bearing means measuring the bearing of the line. Line is OA, OB, OC and OD from the magnetic meridian, always clockwise. So naturally this could be ranging from 0 to 360 degrees. That's the one system. The second system is QB, which stands for quadrantal bearing. Now what the system is, again here in this case, let us say this is the magnetic meridian. So N, this is the point where the observer is, O, and we have again A, B, C and D, some ranging rods, and all these are, we can define them, join them by these lines. So basically we are interested in measuring the bearings of line OA, OB, OC and OD. Now in the second system of bearing, how do we measure it? That's our east, obviously, and west and south. We write the bearings as, let us say I am writing this bearing. This angle measured is theta 1. So the bearing of line OA is north theta 1 east. What did we do here? Look at that. From north to east, the angle is theta 1. So that's why we write it as north theta 1 east. Similarly, I can write it as for another line. Let's say the line is here, OB, and that angle is theta 2. So for OB, the bearing is south theta 2 east. Or also, for example, here, this bearing to OC will be, if this angle is theta 3, south theta 3 west. Now why we are writing it? Because it is from south to west, angle value is theta 3. So this is why we are writing it this way. So this is the another system of writing the bearings, and as is obvious that you can make use of these bearings and you can convert WCB to QB and vice versa. If you know the values in any of the systems, you can convert it as a simple conversion. Now we are going to look into the other thing, some more terms. One is fore bearing and the other is back bearing. It is written also as FB and BB. What these are? Okay, let me draw it separately here. That's the direction of north here, and similarly here also this is the direction of north. There are 2 points, point A and point B, and a line joins these 2 points. I am standing at A, the observer is at A, and this is the direction in which I am proceeding. I am going in this direction in my survey. So if I observe the bearing of this line AB, this particular value, this is called fore bearing. Let's say this is theta F. Then if I have reached the point B, I am at the point B now. Going at the point B, I can measure the bearing of line BA. So I am measuring the bearings earlier as the fore bearing was for AB and the back bearing is for BA. Now how do we decide whether we are going forward or not? It's basically the direction of our movement, and we have taken these bearings as, let us say, theta B. So theta F and theta B. Can you see there should be some relationship between these two values, fore bearing and back bearing? You can make it out very easily from here, that there should be a relationship between these two, and that relationship should be, if you take the back bearing minus fore bearing, that should be 180 degrees. And this is the case when these are observed without any error. There is no error. Then this thing should be satisfied. Okay. Next we are going to, if you have, for example, a traverse, and in that traverse you know the bearings at each point of all the lines. Bearings means, as we know, all these angles of all these lines. You know all these angles. So by knowing these bearings, it is also possible that you can determine these internal angles. I am not going to solve any numerical problem here. Rather, I will advise you to please go through any textbook and solve the numerical problem. It's a very simple problem. If you know the bearings of all the lines, you can determine the internal angles of the traverse. And of course, similarly, vice versa. If you know the internal angles of all the lines and bearing of one line, let's say you know all these, and you know the bearing of one single line, then all these can be determined. Whatever system you want to, in WCB or QB, everything can be determined. Now let us get into that, how we can measure the bearing, measurement. Okay, so we are going to see that how we can measure the bearing. As we have seen what is the meaning of the bearing, this is the magnetic meridian, so direction of north. Our observer is at A and there is an ranging rod at B, and we are interested in observing this angle theta, which is the bearing. Now there are a couple of instruments in order to do that. We are seeing one which is the prismatic compass. I will tell you about the various parts of the prismatic compass now. The prismatic compass comes in a cover. When you open it, it will be clamped like this. What I can do here, I can open the vane number 1 and number 2 here. Now this is ready for taking the observations. We will see the various parts of it, what they are, what they do. Over here, I can tilt it up and keep it on top of the circle. Now this is absolutely ready for taking the measurements. Now on this particular part here, in this vane, there is a little slit, a very fine slit is there. Now what is the meaning of slit? The slit means, if I draw it here, the slit is a very narrow opening, while at the other end, over here in this vane, there is a wire. Wire is on the other end, we have a very thin wire or thread. Now we make use of the compass so that we are looking through this slit and this wire, and we can align it along any line. So I can use my master eye, my right eye, and look through it so that it is aligned along a line. I am at point A, I am looking to point B. Okay. Well, over here you will see there is a mirror also. This is a mirror fitted here. We can tilt this mirror, and the use of the mirror is if the line of sights are inclined. For example, the ranging rod is not horizontally in front of me, rather down there. So I can see the ranging rod in the reflection through the mirror. So this is why we use the mirror. Also we have got some color glasses here. Because we are looking through the slit, we need to see the readings here. So color glasses helps us to reduce the intensity of light sometime when it is required. Now over here, if I show it this way, we have a measuring circle or the graduated circle. We will see the configuration or the specification of this in a moment. Nonetheless, along with this vane is fitted a prism, and the use of the prism is, my eye is here on this side, the eye is kept here, and the graduations are written down there. So what the role of the prism? The prism will take these graduations and will reflect it here. Now there is very interesting thing about this graduations. The graduations in this circle, they are written inverted. Why they are inverted? If this is the prism here and this is the graduation, okay, then how it will be reflected? It will be reflected like this, and this is how it will be seen. So the role of the prism is to invert these graduations, because eye is here. This is where my eye is. We make the graduations inverted in the circle down there because we can see them erected. So the prism erects those inverted graduations. Now we will see it that what this circle is like. Okay, so here we are looking into the construction of prismatic compass, and here you can see that's the body of the prismatic compass. The important thing about it is the graduated circle. Where is the needle? The magnetic needle, because we talk about that the compass is based on a magnetic needle. The magnetic needle in this case is attached with this graduated circle. We cannot see it because it is underneath this white aluminum strip. Now this needle is suspended, or this graduated circle and the needle combined, they are hanging with a very smooth jewel here. This is to ensure the frictionless movement of the needle. Right now, if this is the direction of north, as you can see with the rotation of the instrument, I am rotating the instrument, the needle and the graduated circle, they keep there. Well, this is how you can see they can move. So basically what will happen in this case? The graduated circle and the needle, they always maintain one direction, the direction of the north. Let us say I need to measure the bearing of a point B. What do we do? This is the eye vein and this is the object vein. Here is a little wire and the slit. Well, the person, the observer, keeps his eye here and rotates it so that the eye from here can bisect this particular target or the ranging rod. Now in this case, whatever is the reading over here in the graduated circle is the value of this bearing or this angle. Now we will see how this graduated circle is written, how the readings are written in this graduated circle. Okay, to measure the bearing, as we saw, we keep our prismatic compass at A, as we have seen, and how the prismatic compass, for example, here is the point A, the prismatic compass is graduated in a very typical way, we should know it. Right now, for example, the prismatic compass is kept in such a way that this is the eye vein, the object vein, where a little twine or thread is there, wire is there. This is the direction of north. All these are aligned. So our needle, that's blue line here, having N here, it will be suspended in the direction of the north. So that direction of north is here. Now as you see, this blue line here or this blue circle is the graduated circle which is attached to the magnetic needle. The graduations, they start from 0 over here, then 90, 180, 270. Now why they start this way? We will see it in a moment. Now as you can see here in this diagram, well, in order to measure the bearing of line AB, initially my instrument, my eye vein was here and the object vein was here and I was looking in this direction. Now I rotate my instrument till I bisect this ranging rod at B. So when I bisect the ranging rod at B, as you can see here, what happens there? This needle will stay where it was, because needle is 2 point in the north direction, it will stay there. So the graduated circle will also not move. What moves? Only the instrument or only the body of the prismatic compass. Only this black line, it moves along with the eye vein and the object vein. Now at this moment, if I look through the prism there, the prism is kept here. If I look through it, it will read the graduated circle here. So the reading in this case will be, as you can see, around 45 degrees. And of course, the graduations I have written here erected. They are not erected, they are inverted. Then only this prism will erect them. So our bearing, as you can see here, is around 45 degrees. And this is what we are observing over here. So this is how we can take observations with the prismatic compass. So what we saw today, we saw the significance of the traverse. Okay, we cannot use the simple chain survey everywhere. We cannot use the simple chain triangulation everywhere. So we need to go for traversing. In traversing, we need to measure the angles. We can make use of a very simple instrument, compass, to measure the angles using the bearings. And to measure those bearings, we saw some terms, fore bearing, back bearing, their relationship, and also how we can measure it using the prismatic compass. The prismatic compass, by the way, you can use it either on your hand or maybe in a stand. So you can fix it on a stand and then you start measuring the bearings with that. In the case of the prismatic compass, the moment you bisect something, at the same time you can see the readings also through the prism. Thank you very much.